Students, today I'm going to discuss about how to write program in the Xilinx Vivado. So first we'll create a project by the help of the different steps in Xilinx Vivado. Then in that project we'll create a Verilog program. We'll create a file where we have to write the Verilog code. Then we have to test whether whatever code we have written, is it correct or not. That can be tested by the help of a test bench. So by the software simulation, by writing a test bench, we'll verify whatever code we have written, is it correct or not. Okay, so let us go to the software. There directly we'll go and we'll start the program. By clicking on that Vivado icon which is in your desktop, you will get this page. It will come. Then you have to create new project. So we'll click here. Step by step I will tell what you have to do and why you are doing this. Create new Vivado project. Then we'll go for the next. Then here we have to give a name, project name. Then where we want to save this is the project location and this is the project name. As it is given showing project 1, so I am keeping that one as project name. Then going to the next. So here we are writing the register transfer level project. So we have to select this HDL project. First one by default it will be selected. Either you have to select this one or if it is not selected there. Next, this is add source. Add source means before creating a project, creating a project, we have to create the source or we have to create the file. If you will not create the file also, the project will be created. After that you can create the design source or simulation source. So now I am not creating any source. I am going to the next. I am only creating the project. So next, existing IP which is optional, we don't have to give anything here. We'll go to the next. Then here add constraints which is also optional. This constraints file is nothing but the file which will be used to test your program in the hardware like FPGA board. So for that you have to write you have to add a constraint file. So for time being we are not adding any constraint file. We'll just keep it as empty. Then we'll go to the next. So here is the main thing. Depending on which hardware kit you have, that kit has some name. That name you have to select here. So step by step, first product category is there. So we will use a general purpose FPGA board. First we'll select general purpose. Next we'll go to the family. In the family there will be different. These are the like processors. So what we have in our college, that is ATIC 7 is there. This ATIC 7 is the family, or you can say that this is the processor which is made by the Xilinx. Then subfamily we can select ATIC 7 or ATIC 7 low voltage. So again ATIC 7 I have selected. Next we'll go for the package. So here CSG324. CSG means what? CMOS static gate. So this code is selected. Next we will go for the speed. Speed will be -2. Why I have taken -2? Because whatever FPGA board I have, that is operating with -2 speed. Then here we can see that XC7A 100T CSG324 -2. That board is with me. This XC represents Xilinx Corporation, 7A represents ATIC 7, 100T represents the operating frequencies 100 MHz. Then CSG324 it is CMOS static gate code. Then -2 is representing the speed. Then we'll, after selecting this one, we'll go for the next. Then we'll finish. So by this you can see that now project is created. Once the project is created, next is we have to add the source. The source can be design source or simulation source. You can see here 3 things are here. One is design source, constraints, simulation source. Constraints is needed for testing your code in the FPGA board or hardware kit. Simulation source, it is a testing by the help of a simulation source, which is a software analysis. Then design source is the code or is the logic circuits which you are going to write. So now after creating this project, I can go to add source to add the design source. After add source, you will get here different options are there: add or create constraints, add or create design source, add or create simulation source. So what we will do now, we'll select the add or create design source. Then we'll select next. After that, we have to, if the file is already exist, then you can add files. If you are doing first time, you are going to write the program first time, there is no files which is earlier exist, then we have to create file, and here we have to select Verilog. The file type should be Verilog. Then we'll give a file name. So I am giving this one as a logic gates. And remember that whenever you are giving file names, don't start it from any number or any special character. Always start with some letter only. Then there will be no gap in that name, file name. Okay. So file is created. Next I will finish this one. So before finishing, it is asking whether you are going to give what are the different ports needed for your file, needed for your module or not. If you will not give here, you can write also indirectly in that code you will write, or else we can give here. To give the input and output here is best way. Instead of writing in the code, we can give here. So I'm taking as A and B as my input, and I will take Y as my output. So by default this direction is input, so AB input. Next for output we have to select here output, and here I want let us consider I am taking for AND gate or gate, so I want two output. So I'll create a bus here. I'll create this one. This you can see that this is with respect to MSB, LSB is 0. That means this Y output has two value, one is Y1, another is Y0. This is known as a vector, and AB, this is known as scalar. Since it is not have a bus, so it is only single elements input, so it is known as scalar. This Y is contain Y0, Y1, so it is known as a vector. Now we'll create this one. Now it is not showing here, so if you double click on this design source, you will get the file. So this is the file showing, this is the program it is showing. Now next is we have to write the code in this. And one more thing, whenever we are writing the program, at that time also it was saying to module name. So the same file name whatever I have written, it is coming as the module name. If you want then you can change the module name, but remember that the module name should start with a letter. It should not start with any number. You can start with a letter. You can keep some numbers in between, and there will be no gap in this name. You can use underscore, but there should not be any gap. If you are doing that mistake, then the program will not run. So input is already declared, output is also already declared. Next I have to write the code for AND gate and OR gate. So I'm writing the code on structural modeling. So based on the structure, the code will be written. We already know that for AND gate, two input will be there, A and B, one output will be there. Similarly for OR gate, two inputs will be there, one output will be there. And whenever you will write the code, you have to write in structural level, then you have to call the gates. The structural gates you have to call. So how you will call? First I am writing for AND gate, so I am writing AND. That means I am instantiating, I am calling the AND gate. Then I'm giving the name, any name you can give, G1, that is optional. Then first you have to write the output, then you have to write the input. Why we are writing first the output? Because AND gate, OR gate, any logic gate you are taking, all will have a single output. The input can be more than 2. AND gate can be 2 input AND gate, 3 input AND gate, 4 input AND gate. So if I am writing here Y0, then this is indicating the output, followed by whatever you will write, that will be considered as input. So I'm writing A, comma B, then closing bracket and semicolon. So every times whenever you are writing a statement, you have to close it by the semicolon. By giving this semicolon means you are closing that statement. That statement is ending there. Then I will write another for OR gate. Similarly, OR will give another name G2. Here I will write Y1 A B. Semicolon. So by this, if you'll see the code is complete for AND gate, OR gate. This is very simple code. Only for your understanding I am writing this. Now what we are seeing in this two code, one AND code is AND gate is instantiate, one OR gate is instantiate. Okay. Now we'll save it. After saving, you can see that in this box, which is the hierarchy is written here, this is the source. In this source there is no syntax error. So this is the source. So here you are seeing there is no syntax error. If any syntax error is there, then you have to first correct that error, then only you can run the or you can simulate your code. Let us first I will show some errors. For example, many students are giving here comma. If you are giving comma, then this is a syntax error. Now I will save it. So then I will go to the source. In the source you will see it is showing syntax error. This is the module name. I have written logic underscore gates. It has syntax error. It is coming under syntax error. If it is coming under syntax error, then we cannot run it. Understand? So to run it, first we have to correct the syntax. Then I will go to my code. Here I will delete this one. After deleting also it is not showing that syntax error. Still it is showing that syntax error. So what we have to do? Every time we have to save. Any changes we are doing here, we have to save it. Once I will save here, you will see in design source there is no syntax error. So no syntax error means your file is ready or your module is ready to simulate. But if you are simulating this one, we can have to give the forced constant to get the output. So I want to execute this by using the test bench. So then what we'll do, we'll go to again add source. We'll write a simulation source. I'll click here. You can see that the third option, which is add or create simulation source option, is there. Now we'll go to the next by selecting this one. Then we'll go next. Then here we have to create file. So you can give any name here for better understanding, to later to know which test bench is for which module. You give the same module name underscore tb test bench. So I can write logic underscore gates underscore, in capital I am writing tb test bench. Okay, next we'll finish. Now here it is asking to give the input port and output port, but we know that test bench are only for creating the inputs. That is not a module. So if it is not a module, it will not have input port and output port. So what we'll do, we'll click OK. So here it is asking an pop-up window will come. Definition has not been changed. So here you have to select yes. Now we'll go to the source. Now see here, previously we have created logic gates which is coming under design source. Now I have created logic gates underscore TB which is coming under simulation source. It is not coming under design source because I have selected that one as a simulation or test bench. Now you can ask why this logic gates is coming both in the design source and simulation source, because this logic gates you can simulate by the help of the force constant. So it has to come in both design source and simulation source. But the source which is created as a simulation source, it will come under simulation source. Okay, now we'll go to the program. So I'll double click here, it will appear here. Now we have to write the test bench for logic gates, AND gate and OR gate. So first what we'll do in the test bench, what is the logic? First we have to declare the input as a register, output as a wire. So what are the different inputs and outputs are there in the module, that should be declared here. The name can be different name can be given. So for example, I have taken A and B as my input in logic gates. Now here I will take A underscore T, B underscore T. So I'll declare that one register reg A underscore T, B underscore T. So this is the A and T and B, A underscore T and B underscore T is the input variable for it's not input variable. These are the two variables declared in the test bench which will be used to pass the value to the input terminal which has declared in the logic gates. Okay, so next we'll declare where. So this should be a vector because already we have taken the logic gates module output as a vector 1:0 y underscore t. So now I have declared at, bt, yt. These are the three variables. To a underscore t, b underscore t is declared as registered data type, and y underscore t, which is a variable of size 2, is declared as a where. Now after declaring these three variables, next we have to call the module. But what is our module? You are seeing here logic gates. This is not the module, this is the file name. If you are going inside this one, this part, this is your module. So whenever you are instantiating, this must be same. Even a small letter, if you are writing instead of a capital letter, then it will not take the module because it is case sensitive. So what it is written here, same thing we have to write whenever we are instantiating. So what I will do here, I will select this one, I will copy this one, and then I will paste here. Then we have to give some names, or generally design under test or unit under test, DUT. Then what we'll do, we'll pass these variables to the module. The test bench variables will be passed to the modules. How will pass? By dot a. This a represents the module variable input. In bracket we'll write a underscore t. So a underscore t is declared in the test bench, a is declared in the logic gates module. Then comma dot b underscore t, comma dot y underscore t. As I told you, since y you have taken in the logic gates, if you go logic gates, y is taken as a vector 1:0. So here I have taken the another variable 1:0 y underscore t. Instead of that, if you will take where y1, y2, then this command will be changed. Whenever you are instantiating this dot y in bracket y underscore t, because both are same size, both are vector, so we can pass without mentioning what is the vector, what is the size, vector size. Okay, so that means by this one we are calling this logic gates, which is known as instantiation of this module logic gates, and we are passing this a underscore t, b underscore t, y underscore t variable to that logic gates. Then we'll write the code for it. So code means we have to initialize the input variables. So that can be done by the statement or by the block, initial block. So we'll write initial, then since we have to write many statements, so I'll write begin and end. So in between begin and end I have to write my all statements. So what we'll do first I will give a underscore t equals to 0, b underscore t equals to 0. So here two variables are there. So two variable means in digital we know that there can be 4 different combination 0 0 0 1 1 0 1 1, but whenever we are writing input we have to give some delay. Why? If you are giving not delay, then the simulator will be confused which value it will consider at that time, because all will be executed at the same time. So for giving delay I'll write some hash 10 nanosecond delay I am giving. Then I have to give 0 0 combination already given, so then I will give 0 1, again I will give another 10 nanosecond delay, then 1 0, again another 10 nanosecond delay, I'll give 1 1. So all 4 cases are over. Next what we have to do, we have to finish this execution, or else if you are not finishing then it will go on, the execution will not stop, it will go on. So to stop it I have to give a stop time. I'm taking 10 nanosecond delay, then I can give finish. So that is a system function, we have to write with that dollar symbol, then semicolon. You can see that every statement, at the end of the every statement I am giving semicolon. If any case you are forgetting this semicolon, or instead of semicolon you are giving colon, then you will get a wrong output. Okay, so begin end is over, module end module is over. So the test bench code is now completed. This is the test bench code. Now we'll save it here. Then I'll go to the source to see whether any error is there or not. Now if we'll see in source, we'll see in this there is no errors. Let us give some errors, intentional errors. Let us this and this semicolon in there I am removing. So if I'll save this, what will show it, you'll see that syntax error is there. It is showing logic underscore gates underscore tb. This is the module. This is the file which is having some errors. Then if you are giving here semicolon, then it is no errors is there. Okay, now it is there is no errors. You can do the simulation. One more things you will see. For example, this module logic underscore gates, we are giving some different name. Instead of gates, I'll write only get. Then I will save. See what is happening here. So this under it is coming the dot which is logic gate. Now it is given a question mark. That means that logic gate is not exist. That logic gate module is not exist in the project. And this logic gates is coming out. This is outside the logic underscore gates tb. But if you are writing here s and save it, then you can see that under this logic underscore gets tb test bench source or a simulation source, under that this is the module is coming. Okay, now we'll go for the simulation. So it will take some time to do the simulation. This is a very simple program, so it will not take much time. We are getting the waveform here. Now you will click on this, which is zoom fit. So whatever screen is coming, it is taking all those. So what is there? 001011 is there. See what mistake I have done here. So since I have copy paste the test bench, that is one line is copying twice, instead of 01 I have taken 10 twice. So 01 condition is not showing here. So what we'll do, we'll go to the test bench, see here 101010, sorry, 80 bit is 00 is over, 01 1011 is there. So we'll save it. Then again we'll do run simulation. Then zoom fit. Okay, it is coming all correct only, all are coming. See here I am given, after getting the test bench, then you have to verify the output whether it is correct or not. So what we have taken, this is representing y1, this is representing y0. What y0 y1? If you don't remember, then you go to logic gates. See, y0 is your AND gate output, y1 is your OR gate output. Then go to the test bench graph. So then we have to verify that y0 is my AND gate output, y1 my OR gate output. Now it is given 0 0. 0 0 means OR gate output and also 0, AND gate output also 0. Next I am giving 0 1. 0 1 means OR gate output will be 1, AND gate output will be 0. Then I am giving 1 0. 1 0, OR gate output is 1, AND gate output is 0. Then 1 1, this is 1, this is 1, 1 1, AND gate output is 1, OR gate output also 1. This is correct. So now graph is correct, but is this graph belongs to your test bench code or not? That you have to verify. How to verify that one? See the variables here. A underscore t, b underscore t, y underscore t. These are the variables showing in the graph. But what is the variables in the module you have taken? You have taken the variable a, b, y. What is the variables you have taken in the test bench? A underscore t, b underscore t, y underscore t. So now we understood that in the graph whatever the variable will come, it will come with respect to your test bench. In the test bench, what is the variable you have written, that will be displayed in the graph. So if the test bench variables is differing, like for example here a, b, y, a, b and y is coming, that means this graph is not belongs to your test bench. It may be correct, but it is not belongs to your test bench code. It will be belongs to someone else. Okay, so this is only for knowing how to create a project, how to write a simple program in Verilog in Xilinx Vivado, then how to execute it, how to simulate it by the help of test bench, then how to verify the test bench code and test